उसके बाद में 1 मिनट में बार मेरे पास आएगा। मैं अपना फोन आपके पास दे देती हूँ।
Okay, so we are ready for live. Okay?
Okay. Hi, this is Jhuma Ghosh, curator at Nehru Science Center, Mumbai, and I welcome you all to the first episode of our new show, Online Science Quest. I hope you are all doing very well and you have browsed through our social platform like YouTube and Facebook, as we have promised that we are going to show few videos from our past posts on our Facebook pages, and for the first episode we have chosen just 2 videos out of them on a very random manner, and then we will ask the questions from that videos, and you will have to answer by calling on the telephone number that is given there, or if you have any problem reaching our number, then you can actually let us know your answer by posting it on the Facebook page as a comment. We'll also look at those. I hope you will find those videos familiar because it's already posted there, and if you have searched it, you must have seen it before and you are already ready with the answers. So if you are ready to watch it, I can start it, okay? Let's see the first video. We see an empty glass where we are dropping a bit. We are trying to drop it at the center. Okay, now the bead is at the center of the glass. Okay, we are filling the glass with water, but only up to the half. Now you see the floating bead, it goes towards the glass wall. It's no more at the center. It doesn't matter how many times you try to bring it at the center, but it will again and again go to the glass walls. Do you find it obvious, or do you think there must be some reason because of its some other properties that maybe you can explain? Is there any scientific phenomena that you would like to mention? Then please let us know either by commenting here or by reaching us through telephone. She is trying to fill the glass with water, now up to the brim. You see that the glass is already full, but it can hold more water than its capacity. The bead is still near the edges.
Someone is asking why does this happen?
They have to answer.
So you say you have to answer. Right.
Someone is posting their question, but I would request you, if you have come up with some answer, then please let us know, then we will discuss it here. Now you see that the bead is slowly moving towards the center.
Kruti Jain says force of adhesion.
Okay, someone is mentioning force of adhesion. Can you give a brief explanation with more detail? Okay, if we can just pause the video at this moment, then we will see that the glass is filled, but filled more than its capacity. So you can actually see the liquid surface now, and also you can see that the bead is exactly at the center. Now you have to answer that what was happening when the glass was just half glass wall. Now what has happened now that it has come to the center? What's the reason for this change? You can post your comment. Okay. Priyanka Patel has mentioned the surface tension, but I request you to give a bit more explanation. I mean, okay. Okay, we'll take a phone call.
हेलो
हेलो
ये
हाँ इसका आंसर देने का था
हाँ बोलो आप नाम बताइए अपना
क्या water when the water is not full then the force of cohesion is less and the addition is more so the water sticks to the glass and so the bead floats away from the center but when it is filled the water assumes a convex state and hence it moves towards the center.
can you give your name please name and the school name and from where are you calling
Okay, it got disconnected. But thank you for answering and participating in our session. And I hope there are many more participants who are trying to reach us by calling. Thank you for showing this encouragement. And I will read some comments from here. Mamta Mehta says that it is convex meniscus when it is not full, as cohesion is lesser than adhesion. So the bead floats to the surface when it is filled. The meniscus becomes concave, so it goes to the center.
I think you need to answer
Okay. We will actually discuss the answer at the end, but now I will prefer to take the answers first. Ashwinder Kaur Akal is saying that probably because of air released through the holes of the bead. Okay, it's a guess. Sheetal Modi is saying force of adhesion, but we need some more details. Whatever you think could be an explanation, please let us know. Ritu Garg is saying that it has now gone far away from glass due to the increased level of water. Okay, but can you just guess why it's increasing the level of water? How can the glass hold? It's beyond its capacity. I mean, it's not very usual, right? So try to think from that way, maybe. Okay. The next call.
Hello. Hello.
Hello,
Yes.
I have the answer.
You just mention your name and the name of school.
Abhay Patil. Full CPS, public school, Kasivali Mumbai.
Okay. Go on, please.
Ma'am, the answer is, ma'am, the bead was not floating on the glass of half filled back because the surface tension by the glass, force of the glass. And when you even filled it, it became concave and still, and the surface tension was reduced or neglected. And that's the reason.
Okay.
we have noted your
Thank you so much for answering this question. We have noted your details. Thank you so much. Thank you. Yeah.
Okay. I'll check if we have something else. Okay. Anuradha Sawant has some different answer. what if an oxygen molecule combines with an uranium molecule? What new compound will be made?
Well, this has nothing to do with
Well, we are running a Facebook live session on where we will just pose the question based on these videos, then try to answer that question only.
Hello.
Hello.
Hello. Please mention your name.
Basically, I'm staying with the person who first from you. I am staying with and I'm from Children's Academy, Mumbai.
Okay. I think the
As you were earlier unresponsive, I thought that my call has been cut. I am sorry for that call.
okay. I think the first call was made by you.
Yes, yes.
Hello,
So
Dev.
you had called.
My name, I repeat, I am Dev Mehta. I am from Children's Academy, Ashok Nagar, Mumbai.
Okay. Okay, Dev. We have already.
Can I repeat again?
No need. Actually, we have already noted your answer, and thank you very much for answering to our query.
Thank you.
Thank you.
Welcome.
Thank you.
Okay, Shilpa Kulkarni is mentioning Archimedes principle, but can you just elaborate how are you applying Archimedes principle in this case? Just elaborate it a bit. Don't just mention the property or any theory.
Keep running the video.
Yeah. Maybe Mamta Mehta, you can actually look at the videos that we are showing, and then you can actually edit your answer a bit. You are actually closer to the right answer, but you have just reversed it somehow. I just read it and just look at the videos that we are showing. You will find out what's the wrong here. You will find it out yourself.
Hello. Hello.
Hello?
Yes, may I know your name? Speak loudly. We couldn't hear you. Can you just repeat your name and school name?
Coming from Mumbai.
Are you calling from Mumbai? Okay. Can you just give your answer?
Sufficient.
Yeah, you are mentioning sophistication of water. Can you just mention 2 or 3 lines? I mean, elaborating it a bit. A brief explanation, if you would like.
Your voice is getting there is a disturbance in your there is some disturbance in your voice.
Oh, okay. Thank you for calling and participating. Stay connected and watch our session to get the right answer. Thank you. Shilpa, as you were saying about the Archimedes principle, you were talking about the density of the bead, but how does it explain the phenomena that it doesn't go towards the center? How are you going to explain that phenomena using Archimedes principle? That's actually the question from this video, right? Okay, so just think from that way. Jaideep Pasare is asking if the shape of the glass has any role to play. Not at all. Any shape will work. Okay, Mrinal Gatti is saying that it's a combination of two effects, buoyancy and adhesion. Because of adhesive force between the water molecules and the glass, the water level is highest at the edges. So the water level is concave. As a result, the cork moves to the sides. Okay, that answers the first part of the question. Now, just can you just add one more paragraph explaining the second part where we are filling it up to the brim? I think that will be a complete answer. And okay, it's good. Hi Shilpa Kulkarni, in both the cases when the glass is half filled or it's filled up to the brim, both the cases the bead is actually floating. So there is no such differences if you think from the Archimedes principle side, because in both the cases it's floating. That's obvious, but what our question is that why is it floating either at the center or near the edges? What makes that difference? That's the question, right? Okay, Mamta Mehta has corrected our answer that the meniscus is convex, not concave. Okay. Shashikant Tavre is mentioning center of gravity. How does it play any role? Can you elaborate sometime? Subhangi Patel is saying, what if water was concave? It's not quite clear from your answer what you are actually trying to say. So, please write 2 or 3 lines what you are actually meaning to say. Okay, Ritu Garg is saying that it is because water is less, it is attracted by glass, but when it goes upwards, it gets far away from the glass and force of attraction reduces. Not very clear. Okay, Anita Bali is saying that beads are usually denser than water, so they float or slide on the water surface. Think about it again what you have written. If the beads are really denser than the water, will they float on the water? Think again, think again. Okay. Now, Shilpa Kulkarni is saying that the meniscus is at the highest point in the center, so the bead floats. Okay, that's a good answer, but maybe you can actually elaborate it a bit more, stating the different 2 cases, okay? I mean, how the meniscus is changing or why, just it will make a complete answer. Okay, Komal Vijay is saying it is lighter in weight. Okay, it's lighter in weight, that's why it's floating. But the question is something different. I think you have got it. Okay, I will answer Mamta Mehta. Because of, okay, Rashmi Kodavali is saying that because of water, brim comes in the center. I think if you can explain a bit more, then it will be easier to understand what you are actually trying to say. Okay. Someone is saying cohesive and adhesive forces, but okay, don't ask me. But actually, explain it in 2 or 3 lines how it's playing the role. Okay, then it will be better to understand. Does the water molecules hit the bead and so the bead comes to the center? Not like that.
Hello.
Right.
Please introduce yourself. Okay.
It's disconnected. Ashwini Patel is saying that the surface tension in water owes to the fact that water molecules attract one another, okay? As each molecule forms a bond with the ones in its vicinity, at the surface, though the outermost layer of molecules has fewer molecules to cling to, therefore, compensates by establishing stronger bonds with its neighbors, thus leading to the formation of surface tension. It's not quite clear how you are going to explain the two cases. What makes the difference when it's half filled and when it's filled full? Okay. Ruby Branchal is saying it's because of surface tension. Okay, but we want more elaborate answers. Okay, Mamta Mehta, so it's Dev Mehta who is actually the participants. Okay, thank you. Sarjan Rajput is saying that due to the shape of the water on the surface, the bead is in the middle. Okay, you are just okay. You mean those convex surface? Okay. Someone is again saying surface tension. Yusuf Santosh Viswakarma is saying that is it related to ambition? What are you trying to say? Not quite clear. Aswinder Kaurkar is saying that the gases trapped in the water is trying to be released, moves the water at the molecular level, making it difficult to see but effective enough to move the bead. Okay. Shilpa Kulkarni is trying, okay, good. She's now saying that there is a transition in the meniscus as the water is first convex while filling and then at final point concave. No, it's just the opposite. You can see this is when it's half filled, it's just concave. This is the concave shape, and when it's filled full, when it holds more than its capacity, it becomes convex. That's what we see at last.
Hello. Yes. Please introduce yourself, your name, school name, and then you can answer.
My name is Dr. Vataniki, and the question was that why it is the bead comes in the middle. It comes in the middle because the water current has been filled full. And like when the water has been
voice is not clear.
Because of the pressure of the water level. Thank you.
Hello?
She said thank you and she got it. Who are you saying?
The voice was not
Now.
clear.
Okay. Okay, voice was not quite clear. Okay, we can wait for the next caller. And we have some more comments. Okay, Ritu Garg is saying that when glass is half filled, cohesion is more, but when it gets away from the walls, due to increased water level, that causes cohesion to decrease and adhesion to increase. Okay. Samir Pathak is saying, okay, actually, sorry, it's Prayag Pathak was saying that because the bead has through hole, so water passes through it, and the water unbalanced to bead.
Hello.
Hello?
Yes, ma'am. Please mention your name and then your answer.
And the water unbalanced for me.
Mention your name.
Please mention your name first.
First question.
No, please mention your name first.
नाम बताओ.
आपका नाम पहले बताइए.
Prayag Pathak.
अच्छा. अब आंसर दीजिए.
What? Because the bead has no hole and the water passes through it and the water unbalances the bead.
Okay.
He has actually made comment on the Facebook also.
Okay.
Okay, thank you. Thank you.
Thank
for
you.
participation.
Thank you for your answer. Hello.
Hello?
Yeah. Please mention your name first and then your answer.
Priya Nair.
Sorry.
Priya
Sia.
Nair.
Okay.
And so the answer is when the water is half filled, that time the engine has extra water. So it pulls the piece of plastic near it, and when it's fulfilled, that time there is equal water everywhere. So it stays in the middle.
We have noted.
Okay, thank you. Thank you for participation.
Hello.
Hello.
Yeah. Please mention your name and then your answer.
Hi, my name is Priya Kulkarni,
Okay.
and I'm from class 8, North Point School. The answer to the bead question is that when the water is at different levels, its concave and convex manage to keep changing. So at the initial point it is concave, and later it becomes convex, thus causing the transition in the movement of the bead.
I think she has made comment on the Facebook page as well.
Okay. We have noted your answer.
Okay,
Thank you
thank
for
you.
the call. Let's look at it. Hello.
Hello?
Yes, sir. Please mention your name and then your answer.
Manohar Mengwan.
Manohar.
Mengwan. MJ.
Okay. Okay. Please mention your answer.
Answer. Sorry.
Just a second.
Cut करो बंद करो.
Hello.
Okay. Few more comments we can see, and then we will actually declare what's the answer, and then we will move to the next video. Okay. Ashwinda Kaur Akal is saying that due to the glass being concave at the bottom, the bead does not move, but being convex at the top, exerts pressure from all the directions, pushing it towards the center. Shubhangi Patel is saying, why anything compared to water floats in mercury? That's a different question. Okay, that's we're not going to discuss now. Rashmi is saying that the molecules, probably they heat each other and actually push the bead so that it comes to the center. Okay, I think now I will just discuss the answers. Many of you have attempted. That's very good that you have shown your curiosity and your enthusiasm in participating. Now I will just discuss the answer. Many of you have actually guessed it right, or some of you have gone in a right direction. So what is happening when the glass was half filled, actually the bead was floating near the glass walls. That's because actually any floating object try to float at the highest point on its liquid surface. Now what will decide what's the highest point on the liquid surface? That's where the meniscus of the liquid surface works. So the meniscus actually decides which is the highest point and where the floating object is going to float. So when it's half filled, as I said that the meniscus is concave. That means near the glass edges, the water will accumulate more. That's because of the force between this glass and the water molecules. Now, in the second case, when you are filling it beyond its capacity, then the meniscus is actually changing. As you can see, it's now becoming convex. That means more water near the center. That's happening because of its surface tension. And now, as we have already understood, that bead will go to the highest point at the liquid surface. So it will move to the center when it's fully filled. And now what were my question was that many people were talking about cohesive force. That's fine. That's the reason of the shape of the meniscus. When the glass was half filled, why did it take the concave shape? That's because of that fact that the force between the glass and water molecules is greater than the cohesive force between the intermolecular forces inside the water. That's why the water goes towards the edges more. That's why it takes a concave shape. I think it's now clear to many people who are trying to answer. So if you are fine with the answer, then we can actually move to the next video. Let's see what's there. Okay, we see 4 raw eggs, and one has to poke a hole on the top of the egg just to remove all the contents inside the eggshell. Okay, he's actually masking a tape at the marked points on the surface. That's the safest way to cut it through the edges. You have to be extremely careful when doing that. Okay. Now he has got those half-cut eggshells. Okay, you need just 4 half-cup eggshells. Now we want to check its stability, how much weight it can hold. Okay. We are keeping on increasing the weight on it. It's not broken. Okay, you can see how much weight it's taking. Oh, now it's broken. So now we can guess what's the question now. It's very simple that we know that these eggshells, they are very fragile. It has to be handled with extreme care. But then how is it possible that it's taking so much loads? So as usual, let us know your answers. Okay, we are first caller.
Hello.
Hello, during the egg is in the shape of the arc when it's in that particular form, when the books are being kept over it, an arc is a very strong shape and hence it can easily tolerate the weight of the book. I am Jay Mehta from Children's Academy, Mumbai, Ashok Nagar.
Okay.
Okay, thank you for your answer.
Okay, Aswinder, the question was that how it can hold so much weight, the eggshells.
Hello.
Okay, Shilpa Kulkarni has an answer. She's saying that the pressure gets dispersed equally. Okay, and can you relate it with the eggshells? Why eggshells? I mean, anything special that comes to your mind? Okay, looking at the structure, something. Okay. Okay, answered by Anya Amit Kumar, 4th class student. Okay, she's saying that it's force distribution. Okay.
Hello.
Hello?
Okay, just mention your name and then your answer.
I have the answer, ma'am. The reason is that because the stones can hold more pressure on themselves as they distribute the weight, and thus they take longer shelf life.
Okay, can you just mention your name?
Upper button, full TPS.
From where?
TPS, Mumbai.
Okay. Thank you for your answer. We have noted it.
And that dome shape has also used by NASA to make a home on Mars.
Sorry, NASA to make?
Huh?
What your last line?
I was saying that NASA has also used domes to make home at Mars.
Okay. Yeah. Thank you for your answer.
Okay.
Hello.
Yes,
Hello.
I am.
Yeah.
Huh?
Yes.
I am the answer.
From where you are?
I am calling from Navi Mumbai. Yes, I heard.
Okay. Which school?
The TAG Public School in Mumbai.
Okay. Just give your answer.
The dome shape of the egg allows the egg to hold the weight. The dome shape equally distributes the stress
Okay.
Then it can force over it.
Fine. So you have completed your answer?
Yes.
Okay, fine. Thank you for your call. We have noted the details.
Yes.
Dome shape.
Yes. Okay, Pandya is saying that because the pressure is being distributed to all the eggshells. Okay. Okay, Shilpa Kulkarni is trying to say that the sharp edges or flat edges, that means you're trying to say the surface area. Um, Not just surface area, a bit more. Many people have already mentioned the call. Okay, Mamta Mehta is saying is less pressure in our shape. Okay. Swati Saha, we will discuss the answer at the end. Don't worry. Uh, Sarjan Rajput is saying that the pressure of the book's weight is distributed equally. As we know, the larger area, the less pressure will exert. Okay, Mrinal Kati has an answer. The egg is strongest at the top and the bottom because our shape strong at the highest point. That's why the egg doesn't break when you add pressure to both ends. The curved form of the shell also distributes pressure evenly all over the shell rather than concentrating it at any one point. Okay. Swinder is saying due to the pressure equally dispersed and the holes creating vacuum and the tape acts as a support to the shell. We just masked with the tape just for cutting, and the hole was there just to remove the ingredients what was inside. That's why we did that. Okay, Ritu Garg is saying that due to increased surface area and also due to their shape, it's like a streamlined body which helps the eggshells to distribute weight among themselves too. Okay. Okay, Sneha is mentioning about the composite material of the eggshell. Okay. Anita Sampath has an answer that the egg's unique shape gives it tremendous strength despite its fragility. Eggs are similar in shape to a three-dimensional arch. Okay, one of the strongest architectural forms. The egg is the strongest at the top and the bottom. This also explains how a hen can sit on an egg. Okay. Swati is saying that the load is divided. Yes, it's divided, but still, if you consider the load on a single eggshell, it's still very, very large. Okay, Shubhangi Patel is saying that the dome withstands more load as they distribute the weight.
Hello.
Hello, ma'am. The date of books are very high and loaded.
Okay, can you please mention your name? Okay. And now give your answer. You're from which school?
Select Academy High School.
Okay. Give your answer.
What?
Just give your answer once again.
Because of course we have not stopped and there was very load of our books, outside of books.
Okay, that's what your answer is?
Yes.
Okay, thank you.
Yeah. Thank you.
Okay, Shidal Modi is saying that because of egg shape, force gets distributed easily. Okay. Gayatri is saying that egg changes its shape from oval to dome. Dome shape distributes the pressure equally and can hold more weight. Okay. Yeah, Ritu, we will actually discuss it at the end, but now as we are taking many answers, that's why I'm not declaring what's right or what's wrong. I just want to gather all the answers, then at the end I will obviously discuss what's right or not. So just please be patient and stay connected. Okay, Shavana Mumi is saying that the eggshell distributed the pressure equally and hold the load. Okay. Okay, Sujata Wakali is saying that the carved egg shape bear heavy loads. Okay. Okay, Munira is mentioning about several dome-shaped architecture like Taj Mahal, etc. Right? Samruti is saying that the weight is distributed among the eggshells, but still, if you consider just one eggshell, still it's a high load for them. Aswinder is saying that the egg is used to this type of force on it because when it's force because when its mother sits on a specific amount of force, it's not quite clear what you're trying to say. Okay. Okay, I have got what Munira is saying, that the carve shaped makes it possible to be at the weight. Swati Saha is saying because bottom of egg is not carved. But that's not exactly what the reason is. Okay. Okay, I think we have enough answers and most of the people could guess it correctly. The thing is that it's not exactly because of the distribution over all the eggshells, but because of the individual eggshell structure. If you look at it, it's not exactly cone, but it's actually dome shaped. And dome shaped architecture is something that gives you the largest surface area using least material. That's why many people has also mentioned that in ancient day also people has built the roof in a shape of dome structure because it maintains the structural integrity, and actually engineers have experimented and many more shapes, and they have found that this dome structure, which has no corner, no angle, it actually gives you the most stable structure. That's why in architecture engineering, while they want to make some air inflated large structure, they prefer this dome structure because if you apply pressure on top of it, it will get distributed all over the surface. It won't remain concentrated at any single point. That's what gives it the stability. So it has numerous applications. So today I have actually discussed the videos on two topics. The first one was mainly on the surface tension, because of the surface tension the water meniscus in the second case that was convex. You can already guess that thing now. In the second case, it was just like a geometry question, so it was a bit easier to guess. Now, you can find many examples of applications of surface tension in nature as well. Like, I don't know, have you ever encountered with water strider? It can literally walk on the water. And there are also some not so well known example like creation of wave. Actually, the surface tension plays a great role while the transfer of energy from the air or breeze to the water. Now, your job will be to browse through the internet and find out more examples of application of surface tensions in nature and find out some more details. I think that will be fun learning. And also in the second case, you will find numerous applications, even now it's going on the dome-shaped structure. So that was the science and physics discussion for today. I'm very happy that many people have joined us, they have connected with us, and they have showed their enthusiasm by connecting through us over phone, or they have comment. I'd like to announce that the second episode, it will also be in the next week, next Wednesday. So be prepared till that, and don't forget to browse through our social platform, because as you already know that the questions are already there posted on Facebook or YouTube, so you can actually stay prepared with your answers. So browse through it, just closely watch all the videos that's posted here, and then just come back with us again next week. Till then, stay safe. Thank you.